Picture this. It's 1977. Platform shoes, bell-bottoms, and the dawn of the disco era. And amidst all the glittering grooves, NASA launches two ambitious spacecraft, Voyager 1 and Voyager 2. Their mission, a grand tour of the outer solar system.
A 5-year mission, they said? Just a quick peek at Jupiter and Saturn?
But little did anyone know these plucky spacecrafts would become so much more. They'd become humanity's farthest emissaries venturing beyond the heliosphere and into the uncharted territory of interstellar space. Billions of miles away, still sending back whispers of data after over 45 years. It's a story that captures the imagination, doesn't it? This tiny spacecraft launched when disco was all the rage, still out there exploring the unknown. Welcome to Cosmos, and Apollo the Space and Astronomy series. Please like, comment, share, and subscribe. Now back to Voyager 1. This recent silence, it was a little unnerving to say the least, wasn't it?
Oh, absolutely. Definitely raised the tension levels at mission control. You have to consider the sheer distance. Voyager 1 is over 15 billion miles away. That means a signal takes nearly 23 hours to travel one way.
Wow, a 46-hour round trip just to say hello, are you there?
Yeah.
That's mind-boggling.
Yeah.
But I remember reading they did eventually reconnect with Voyager 1.
They did, and it's really a testament to the foresight of the original Voyager team. They equipped the spacecraft with a backup S-band transmitter, a system that had been dormant since the early 1980s.
Wait a minute, so they had a vintage communication system from the disco era just waiting in the wings.
Exactly, and that's what saved the day.
It's like finding a spare tire in your grandpa's attic, and it turns out to be the perfect fit for your modern car.
You could say that. Back in the 70s, the team knew they were building something extraordinary, something that might just keep going beyond its initial mission.
So they built in these redundancies, backup systems just in case.
Precisely.
And it paid off decades later.
It's a testament to the robust design and meticulous engineering. They used radiation-hardened technology that could withstand the harsh conditions of deep space.
It's fascinating that technology from the 70s is still working in the depths of interstellar space. I mean, how many things we use today will still be functioning 45 years from now?
It really speaks to the quality and craftsmanship of those early space missions. But it's not just the hardware, it's also the software. The commands sent to Voyager 1 are meticulously crafted. They have to account for the limitations of aging technology and those vast distances.
Right, so you've got this aging spacecraft, billions of miles away, running on a power source that's slowly decaying. And then you're sending it commands that take almost 2 days to arrive. It's a delicate operation, to say the least.
You could say that again.
And I imagine there's the constant battle against radiation, the
Yeah.
extreme cold, and just the general wear and tear that comes with 45 years of continuous operation.
Absolutely, it's a constant challenge.
Like trying to keep a classic car running smoothly while driving across a continent. Except the continent is interstellar space, and the car is constantly being bombarded with cosmic rays.
That's a good analogy.
So how do they even begin to address these challenges? It seems like the odds are stacked against them.
Well, one of the ways they combat radiation damage is with a clever trick called annealing.
Annealing.
It involves periodically activating the spacecraft's heaters to warm up its electronics. It's a way to repair some of the radiation damage.
So they're basically giving Voyager 1 a space spa treatment to keep it going.
You could say that.
That's ingenious.
It's a great example of the creative thinking that's needed for a mission like this. But even with these precautions, you're always going to face unforeseen challenges. Remember that communication blackout we talked about?
Yeah, what was the cause of that again?
It was triggered by a heater activation.
Really?
It seems the heater accidentally triggered Voyager 1's fault protection system. It's a safety mechanism designed to conserve power if there's a malfunction. But in this case, it also shut down the primary transmitter.
Wow, so even the safety systems can backfire.
It just shows how complex this whole operation is.
And they're doing all of this while communicating with a spacecraft that's billions of miles away. I remember reading about this global network of giant antennas. The Deep Space Network, right? DSN.
Yeah, that's right. It's our lifeline to Voyager 1. We're talking about massive radio antennas located in California, Spain, and Australia. They're what allow us to send commands to Voyager 1 and receive its faint signals.
It's mind-boggling to think about picking up a signal from something so small, so far away.
It's like trying to hear a whisper from across a continent. The signal is incredibly weak by the time it reaches Earth.
And then you factor in that 2-day delay for every communication. It's like playing a game of chess where every move takes 48 hours to execute.
You got it.
So despite all these challenges, Voyager 1 is still out there sending back valuable data.
It's incredible, isn't it?
Absolutely incredible.
And in our next segment, we'll dive into what Voyager 1 has been teaching us about the mysterious realm beyond our solar system.
I can't wait.
Welcome back to Cosmos in a Pod.
It really is remarkable to think Voyager 1 is still out there after all this time. This little probe launched in the 70s, still going strong and exploring the unknown.
And not just exploring, sending back incredible data about a region we've never directly observed before. Interstellar space.
Right. We left off talking about the challenges of keeping Voyager 1 running. But let's get into what it's actually teaching us about this mysterious realm beyond the heliosphere.
It's fascinating stuff. Before Voyager, we could only theorize about the interstellar medium, the vast expanse between the stars. But now we're getting first-hand data on its density temperature composition.
So it's like having a weather station in another star system.
That's a great way to put it.
So what's the interstellar forecast? Is it just a cold, empty void, or is there more to it?
It's definitely not empty. The interstellar medium is filled with this thin soup of charged particles, atoms, and cosmic rays.
Okay, so it's not just an empty vacuum. What kind of details are we getting?
Yeah.
What's surprising the scientists?
Well, one of the most intriguing findings has been the detection of shock waves, kind of like sonic booms caused by eruptions from our own sun.
Really? I thought Voyager 1 was beyond the heliosphere, the sun's sphere of influence. Are you saying the sun's reach extends farther than we thought?
That's right. The heliosphere isn't a hard boundary. It's more like a bubble that expands and contracts with the sun's activity.
So even billions of miles away, Voyager 1 is still feeling the effects of our sun.
Exactly. Voyager is showing us that the interaction between the heliosphere and the interstellar medium is much more complex than we initially thought.
Fascinating. What other surprises has Voyager uncovered out there?
It's also provided insights into the composition of the interstellar medium. For example, Voyager 1 detected a higher-than-expected abundance of cosmic rays.
Cosmic rays, those high-energy particles that zip through space at incredible speeds.
Right, those are the ones.
I remember reading they can be harmful to astronauts and even mess with electronics.
They can be, but they're also incredibly valuable for scientific study. They originate from events like supernova explosions and black holes, so studying them helps us understand the larger universe.
Wow, so Voyager 1 is not just exploring interstellar space, but also giving us clues about the wider cosmos.
Exactly. It's like piecing together a giant puzzle, and Voyager's providing some of the most crucial pieces.
Incredible. Voyager 1 has been operating for almost half a century. What lessons have we learned from its success that we can apply to future missions?
Well, Voyager has shown us that long-duration missions are not only possible, but essential. If we want to truly understand the universe, we need to think in terms of decades, not just years.
That's a great point. Any other key takeaways?
Definitely, Voyager has also demonstrated the importance of robust design redundancy and adaptability, especially when you're dealing with the unknown.
Speaking of adaptability, wasn't there a recent issue with one of Voyager 1's instruments?
Oh, you're talking about the anomaly with the Attitude Articulation and Control System, or AACS for short.
Yeah, that's the one.
That system is crucial for keeping Voyager 1's antenna pointed towards Earth, so we can stay in communication.
So if the antenna drifts off target, we could lose contact with Voyager 1 for good.
That was the concern.
I bet that caused some sleepless nights in mission control.
It did, but the engineers came up with a solution. A brilliant solution, as always.
What did they do?
They realized that the AACS was sending its telemetry data to the wrong computer on board the spacecraft.
Really? So it was like a routing error.
Essentially a software issue. They uploaded a software patch that redirected the data flow. Problem solved.
Amazing that they could fix that from billions of miles away.
It really highlights their expertise and dedication.
So we've talked about how long Voyager 1 has been going and how it might continue for a while longer. But what happens when the power finally runs out?
Well, as the plutonium power source continues to decay, they'll have to prioritize which instruments to keep running. Eventually, there won't be enough power to operate any of the science instruments.
So Voyager 1 will eventually fall silent.
Yes, but even then, its journey will continue. It'll keep drifting through interstellar space, carrying its golden record, a silent ambassador for humanity.
It's a poignant thought, this tiny spacecraft carrying our hopes and dreams, venturing into the vast unknown. I wonder what might become of it millions of years from now.
Who knows, perhaps it will encounter another star system, or maybe it will drift undisturbed for eons. Either way, its journey is a testament to human curiosity and our desire to explore.
A legacy that will inspire generations to come, for sure. We haven't even touched on the golden records themselves. Those time capsules of human culture sites, sounds and greetings attached to each Voyager probe.
Ah, yes, those iconic golden records, a message in a bottle cast out into the cosmic ocean.
It's a hopeful thought, but also a bit daunting, isn't it? Sending a message out there without knowing who or what might find it.
It is, and it leads to some intriguing questions about the implications of contacting an extraterrestrial civilization.
Questions we'll delve into in the final part of our deep dive into Voyager 1. Welcome back to Cosmos, in a podcaster. We've been on this incredible journey with Voyager 1, haven't we?
We have, from those tense moments when we lost contact to the incredible discoveries it's made in interstellar space.
It's a story that never gets old. Human ingenuity, resilience, and that urge to explore the unknown.
Absolutely, and as we venture further out there, it's crucial to consider not just the scientific impact of our actions, but the ethical implications as well.
You're right, we were talking about the golden records earlier, those time capsules of human culture attached to each Voyager probe. It's beautiful in a way, sending a message in a bottle out into the vast cosmic ocean. But it does make you wonder, what if an extraterrestrial civilization were to find them?
It was a bold decision to include the golden records. Some might even say risky.
Risky how?
Well, we have absolutely no way of knowing how an alien civilization might react to them.
Right, it's like sending a signal into the darkness without knowing who or what might be out there.
Exactly. There's no guarantee they'd interpret our message the way we intended. I mean, think about how much miscommunication happens right here on Earth between people who share a common evolutionary history.
So you're saying it was reckless to send those messages?
I wouldn't say reckless. There are definitely different viewpoints on this. Some believe we should have been more cautious, waited until we had a better understanding of the universe and the potential risks before announcing our presence to the cosmos.
So essentially, they're worried we might be inviting trouble, that some advanced alien civilization might see us as a threat or a resource to be exploited.
That's one concern. Others worry about cultural contamination.
Cultural contamination.
The idea that contact with an alien civilization, even through a message like the Golden Record, could drastically alter our own cultures and values.
That's a fascinating thought, but there's also the flip side, right? The idea that reaching out is a fundamental part of being human.
Absolutely. Many believe we have an obligation to try to connect with other intelligent life. They argue that the potential benefits outweigh the risks.
What kind of benefits are we talking about?
Think about the knowledge we could gain, the perspectives we could share, if we were to make contact with another intelligent species.
It's the age-old question, are we alone in the universe? Finding out we're not would be a profoundly transformative experience for humanity.
It would, and even if the chances of the golden records being found and understood are slim, the act of sending them is a testament to our curiosity and our desire to connect.
It's like planting a seed. We may never see it blossom, but the act of planting it speaks volumes.
Beautifully put. So where do we go from here? What lessons can we learn from Voyager, both scientifically and ethically, as we continue to explore?
Voyager has shown us that long-duration missions are essential. If we want to unravel the secrets of the cosmos, we need to think in terms of decades, not just years.
And we need to be prepared for the unexpected. Voyager has faced countless challenges, but it's persevered thanks to the ingenuity and dedication of the teams behind it.
Exactly, and the Deep Space Network, which allows us to communicate with Voyager. It's a global effort with antennas all over the world. A reminder that space exploration is a shared human endeavor.
And ethically, the golden records have sparked a crucial conversation about our place in the universe and the potential consequences of our actions. As we venture further into the cosmos, we need to carefully weigh the risks and rewards of contact and develop ethical guidelines for how to interact with an alien civilization if that day ever comes.
It's a lot of responsibility, but one we can't shy away from.
Agreed. The future of space exploration holds so much promise, but it also comes with great responsibility.
So as Voyager 1 continues its journey into the unknown, carrying its message from Earth, it serves as a powerful symbol of human achievement, but also of the challenges and responsibilities that lie ahead.
It's a story that inspires us to reach for the stars, but also to tread carefully and thoughtfully as we explore the vast expanse of time and space.
Well said. It's been a privilege exploring the story of Voyager 1 with you today.
The pleasure was all mine.
And to all our listeners out there, thank you for joining us on this deep dive. If you enjoyed this episode, be sure to follow and subscribe to Cosmos in a Pod and our YouTube channel. For more awe-inspiring stories from the universe, the journey of discovery never ends.